Hey everybody, welcome back to a new video. In today's video, we'll be testing and reviewing the Epoch 460 amp hour lithium iron phosphate battery. Now I've had a lot of viewers reach out wanting me to check out this battery because it has really good build quality, it has a great feature set, and the price is actually pretty competitive, especially when compared to Battleborn batteries. Now first off, what is this battery for? Well, this is meant to be a drop-in replacement for a lead acid battery bank. For example, if you have lead acid batteries in your camper, trailer, or RV, or even in a boat or off-grid cabin, this is meant to replace those lead acid batteries. Instead of having a bunch of batteries wired together in parallel, you can have one large maintenance-free battery. Now this battery is rated at 12.8 volts nominal with a total capacity of 460 amp hours, giving you a watt-hour capacity of 5,888 watt-hours. Now I know a bunch of numbers like that can be confusing, so let me give you a real-world example of what this is equivalent to. So if I wanted to build a lead acid battery with the same capacity as this, I would need to buy almost 10 100 amp hour lead acid batteries. For example, each 100 amp hour battery can only be discharged 50% before it's damaged, so you can only get half the usable capacity, which is about 600 watt hours. So if we divide 5,888 divided by 600, that gives us like 9.8 batteries. So you'd have to have almost 10 lead acid 100 amp hour batteries to equal the same capacity as this battery here. Now, just to give you an idea of what those cost, a Duracell 100 amp hour deep cycle battery costs around $250. So if you had 10 of those, that is way higher than the price of this battery alone. Also, it's going to take up way more space and you're going to get less charge cycles. So lithium is kind of in a good place right now. Now let's break down some of the features of this battery, starting with Bluetooth connectivity. Trust me, for a battery this big, you really want to know what's going on inside. Now you do have the ability to use their app on iOS or Android, and once you connect, you can see the state of charge of the battery, you can see the voltage of the battery, you can see the amperage going in and out, and also the remaining amp hour capacity. Checking out the second page, you can see the individual cell voltages. You can actually see 4 different temperature sensors reporting back to the BMS about the internal temperature of the battery. Now speaking of temperature, you do have the ability to use this battery in cold climates or all year round because it has built-in heaters. If you need to charge the battery below freezing, the heaters will turn on, they will warm up the battery, and then it will start to charge. Also, this battery has an IP67 waterproof rating, meaning that you can use it in a marine environment or where it's exposed to the elements with no worries about water getting inside. Now there are a few additional accessories that come with the battery to make it easier to use. So the first one is actually this remote on and off switch. Now this connects into the side of the battery here, and you have a 10 to 15 foot cable that allows you to turn the battery on and off remotely. So if this is off in a storage cabinet, or a place where you can't easily get to it, you can route this down there and you can turn it on and off. Now the battery itself does have a power button, so it's nice to be able to turn it off if you're not using the battery to not have any background power usage of the BMS or of the Bluetooth. Now the next accessory that comes with it is the state of charge indicator. Now when you connect this in, it has 10 sections that light up. And I tested this. This is at 90% state of charge, and the state of charge indicator had 9 of the sections lit up. So it was basically showing that 90% of the battery was left. So this is actually based on the state of charge of the BMS, not on battery voltage, which is pretty cool. Now the last thing that's cool about this is this wiring harness here. Basically this has the ability to connect up to a Victron inverter for communications. And unfortunately, I don't really have a way to test that. I don't have any Victron equipment, but I have seen some other videos where this does integrate into a Victron system fairly easily. Now here's a closer look at the battery. You have your main negative terminal here. You have your main positive terminal here. These are M8 screws, which are similar to 5/16 in size, but they do have a different thread pitch. Now the entire battery is made of this durable plastic case. Now you do have these holes along the bottom on each side for attaching mounting hardware, and you do have these carry handles, which you will definitely need because this battery comes in at 97 pounds. Now if you look at the top, you do have a heat sink that comes in contact with the BMS to keep it cool. Now taking a closer look at the side of the battery, you have a vent here. You have your main power switch with a light that indicates Bluetooth is enabled. You have these switches here that control communication and battery settings, and also this port that I mentioned earlier where you connect the remote on and off switch. Now on this side of the battery, we have two of these waterproof connections. One is for that remote display showing the state of charge of the battery, and the other is for connecting to Victron power systems. Now before jumping into the actual tests on this battery and the teardown, I want to talk about just a few more specifications listed here. Now first off, this can handle a continuous discharge of 300 amps. That's almost about 4,000 watts, kind of depending on the voltage of the battery. Now it is rated for 500 amps for 30 seconds. That is a ton of power from one battery. Now you do have the ability to connect this battery together in a 4S configuration for a 48 volt battery, or you can also wire them together in parallel up to 4 batteries. So that gives you a massive battery bank. Now as for the dimensions, it is 20.9 inches by 8.7 by 12.1. So you'll have to measure where you want to put this battery and see if it'll fit, because it is fairly large. Now the first test that I wanted to do on this battery was a complete discharge test to see if we could pull the full rated capacity of 460 amp hours. Now as I started the test, I was able to track all the power coming out of the battery using this inline shunt. You could see that I was discharging the battery at a 0.2C rate, and after about 4 hours and 50 minutes the battery was dying, and we pulled a total of 470 amp hours, or 5,980 watt hours. So we did pull over capacity while discharging this battery. Now in the next test, I wanted to see if this battery could handle the continuous discharge rate of 300 amps without an issue. So I connected up 2 separate 2,000 watt inverters and kicked on a load. Now the first load was right around 335 amps, and I let this run for about 10 minutes, didn't have any issues. Then I stepped it up even higher to almost 390 amps. Now this was almost 5,000 watts of power. Now my wires were getting a bit toasty here, so I actually decided to stop the test. Didn't want to melt any wires, but very high power output available from this battery. So after both those tests, you can see that this definitely performs well. We pulled over the rated capacity, and also we were able to pull over 300 amps continuous on the discharge test. Next, I want to see if we can get the low temperature charging protection to work, or to enable the heaters. But the only way to do that is by taking off the top of the battery. So we'll go ahead and do that, see the build quality inside, and maybe we could tear it down a little bit farther so we can access the temperature sensors. We'll have to see how hard that is. Wish me luck, we'll get started. Okay, so I've removed all the screws around the outside, and each of these terminals kind of have like a silicone or some sort of sealant that you have to break. So you can see I've broken that sealant up, and you take screwdrivers and you kind of pry it up, and then you can get access to the inside of the battery. And man, this thing is built amazingly. This is definitely the best battery that I've ever torn down. So right here you have your main negative terminal. Look at this post, that's so cool. Then it goes through these massive bus bars. So you have your main negative connection for the internal cells down here, goes through the BMS and then out to the negative terminal here. Now all the wiring is very neat, tidy, it's all zip tied. All the connections for the BMS are glued in. Now I am seeing on the BMS it says it's rated for 300 amps, we verified that. And you have this heat sink on top of the BMS here with this thermal pad. And then remember, the lid of the battery has a massive chunk of aluminum as well. So what's cool about this is, you know, every single BMS, when you're loading it down, it will get hot. But in other batteries, the heat has no way of escaping, so it, you know, kind of heats up the actual cells. But with this, I'm guessing that a lot of the heat dissipates through the top heat sink, so that's really cool. Now I'm seeing a large metal plate. Basically the BMS is sitting on a large metal plate. It's secured in probably 10 areas. Over here you have your positive terminal, and then a massive fuse. Now, I guess if you were to blow that fuse, it should be easy to replace that. The lid did come off pretty easily, so it is nice to know that replacing that fuse, you know, it's rated for 500 amps, should be pretty easy to replace. Now, unfortunately, maybe those, oh man, I don't think I can get access to the temperature sensors. Let me take a closer look, see if I can get access to the temperature sensors. Maybe we can do some cold temperature testing on this. Okay guys, I've been looking for these temperature sensors, trying to track them, and I think I found two that go down with the balance leads into the battery compartment. So I think those are the low temp sensors. And then I see two that go up to the terminal. So I have one that's on the positive terminal, and I have one that I've removed that was on the negative terminal. And I think these are for high heat, kind of like a high heat protection. So what I want to do is I'm going to apply a heat gun to that sensor. And I have my battery charger, well, this is kind of just an adjustable power supply, but I have this set to 14.6 volts and 5 amps. So you can see it's charging the battery at 5 amps. So what's going to happen is we are going to apply heat to this, and if it shuts off, we should see this amperage drop down to 0 and the voltage jump up to 14.6. So I'm going to apply the heat gun to this sensor, and we're going to see if it shuts off after, it gets hot. Okay, so take a look at that. It has now stopped charging. So it definitely is a high heat sensor. So if we give that a few minutes to cool off, this should start charging.
A few moments later.
So with the magic of editing, you can see now it is charging again because the sensor has cooled off. So it appears that the two sensors on the battery terminals are for high temperature, and then the two sensors appear to go down into the battery compartment. So I don't think I can access those. They are just so secure, buried down deep inside this battery. Okay guys, I've just barely got the battery put back together. Pretty easy to put it back on with all the screws that go around, and I did verify that everything was working. I was able to charge it and discharge it just fine. The Bluetooth connectivity, all that still works. The only worry that I have now that I've taken the top off is the seal around these terminals is now broken, so I'm going to have to find a way to seal that up because I definitely still want to use this battery. Now as for the build quality inside, super impressive. Probably the best battery that I've ever torn down on the channel, so thumbs up to Epic Batteries and their build quality. Now what about the price for this battery? If you check out their website, it's available for $17.99 right now, which is actually 30 cents per watt hour. Now looking at that 30 cents per watt hour, that's actually pretty decent for a battery that has Bluetooth connectivity, built-in heaters, the Victron communications, and also the IP67 waterproof rating. So really good price for the feature set of this battery. Now one thing that's really cool about Epic Batteries is that they are a local US company, they're veteran owned, and they're right outside of Atlanta, Georgia. So if you live locally to them, go ahead and stop by. If not, you still have the ability to call them over the phone or email them. And I think their website even has a chat option where you can find out more about their batteries. I will include a link to this down in the video description if you guys are interested. And they also offer an 11-year warranty on this battery, which is the longest warranty that I've seen on a battery so far. Now from this video, you guys can tell that this is the ultimate 460 amp hour battery. But if your budget doesn't allow for a battery this large or with this many features, don't worry. Epic Batteries is coming out with an Essentials version of this same battery. It's the 460 Essentials. It's available for pre-order on their website. It does come in at a lower price if you're looking for a battery that doesn't have quite as many features. Now guys, thank you so much for watching the video. A special thanks to Epic Batteries for sending this out for review and testing. If you like the video, please smash the thumbs up button. I'm going to recommend a couple other videos that you can check out if you like this type of content. Thank you guys so much. We'll see you guys in the next one.